So how do you do? All right, so if you want to solve for the values of L given different values of K, the first thing you probably want to do is to solve this equation for L, right? So you have L, it's going to be equal to Q divided by K, which is raised to the 1/2. And all of this is going to be raised to 1/1/2 if you want to simplify this equation for L. And now you know that Q equals 50. So all you have to do to find the values of L is to plug in 50 for Q and the different values for K, 20, 50, 100, and 125. And if you do that, the values you will get for L, the values you will get for L, hopefully you got those values is 125, 50, 25, and 20. So what does this mean? It means that you can produce 50 units of output. If your production function is this way, you can produce 50 units of output using 20 units of capital and 125 units of labor, or you can produce them using a little more capital, 50 units of capital and less labor and 50 labor, or you can produce them with either more capital, 100 units of capital and 25 units of labor, or by using even more capital and less labor, 125 and 20. So let's call this 5 different production possibilities you can have, A, B, C, and D. In all of them, you are producing 50 units of output. Right? So you can replace one capital for labor in this production function, which is something realistic. Now the second thing that is really useful with this production is that it does exhibit diminishing marginal returns to each input. For instance, consider that when you are actually producing a D when you're using 20 units of labor and 125 units of capital. Let's say that instead of doing it that way, you decide to do it with C. Well, to go from D to C, what you do is to trade 5 units of labor for 25 units of capital. Right? You were able to replace 5 units of labor for 25 units of capital and produce the same amount of output. Now you have more labor at that point. Now let's say that at that point you want to even get rid of some more capital, and you want to replace it with labor. Well, how much more capital you will have to, how would you replace labor for capital at that point? Well, at that point you will replace from C to B. You replace capital. Well, you get rid of 50 units of capital with 25 units of labor. So you notice that your labor actually did not give you need a lot more labor to replace the capital when you go from C to B than when you were going from D to C. See, in this one labor actually was able to replace 5 units of capital. But in the other one, on this one, when you already had more labor at 25, your labor did not replace capital at the same rate. One labor actually replaced only 2 units of capital. So what you're seeing here is that the labor is actually less productive every time because it replaces less capital. You need more labor to replace capital the more labor you have. Same thing when you go from B to E. From you go from B to E, you will need how much? 75 units of labor to replace only how much? Like 30 units of capital. So you see that at that point, it will labor is not so productive, and you will need a lot of labor to replace your capital, substitute for your capital. And the same will happen if you're going from A to B, in which you're actually replacing capital for labor. So for both inputs, this production function does exhibit diminishing marginal returns to the input, which means that when you have very little labor, each additional labor is very productive. But when you have a lot of labor, each additional labor is less productive than when you have very little labor. Now we can also see this in a graph, and we're going to do that next.